Okay, well, I apologize for that. Some technical difficulties. Um, but anyway, I was able to get back in a reasonable amount of time. So um, let me go ahead and open us up in prayer, and then I'll get into some of the details I'd like to have us chat about today. So, dear Heavenly Father, Lord, thank you very much for the chance to be working with each of the students in this course, Lord. Pray that you would be working a mighty work in them as they prepare for their future professions. Pray that you'd also help them in their time of spiritual formation at APU, that they can learn more about Scripture, learn about the theological concepts in which we want to be guiding our lives by, and give them interesting and creative ways for faith integration in their future. In Jesus' precious name, we pray. So let me just get a few things opened again, and then like I was saying, one of the things I wanted to go over was a little bit more developed type of Java program. And so what you guys are doing with your projects is based on a theme. You're not just doing an implementation, and so creating a driver program, but you're actually making an application. And so what I'm going to show you is going to give you some perspective on what that might look like. And so maybe as I'm getting that all set up, does anybody have like a piggy bank at home or had one when you were growing up? Maybe that gives a concept per se of what I'd like to have us be thinking about here. And let me just pull up my desktop and I'll show you. So what are the characteristics that we're going to be showing here to give some basis of an idea? So this to be full screen. So we start with our bag interface. Okay, we have that. And so, as I said, there's actually more methods here than what we're going to be dealing with as we get into stacks. But that aside, this is the first one that we have. And just using some of the features of Eclipse, if I click over here, I know it's kind of hard to read, but if you were to pull up some of the sample code that I got, or just anything that one of the bag interface, you can see that here are the methods that we have. Get current is empty, add, remove, there's 2 removes. And so you're removing just anything, removing a particular item. You can clear the bag, you can get a frequency of a certain element, see if it contains, and have everything go out as an array. So that's all stuff that you're familiar with now. And in terms of the one chart that I show a lot, let me just pull that up briefly. So we start with the interface, and what this does is it creates a set of features that's supposed to be exposed to the user. And the implementation is something that we can do. We can make up our mind on what that would look like. And so the two implementation choices that we've talked about so far is either doing an array implementation or a linked implementation. Soon we're going to get into these other things. Well, what about if we're going to use recursion or iteration, sorting? And then we have to be thinking about what algorithm searching and what algorithm are we going to be using for that. And so those are things that will start to come up as we move forward. So that's the first thing that we have is we have the interface. And so what is the next thing that we want to be doing if we're going to be using this as a template? What's the next .java program that we should have? Anybody want to give me your sense of what you think that should be? You either can use a chat or go off mute.
Sorry, Professor, could you say the question again?
What I was asking is, given that we have an interface and we want to be writing a program, I'm going to be showing this one in more detail about creating a virtual piggy bank. What do you think the next thing that we would want to be doing in terms of we start with the interface and we want to implement that interface? And so what I'm wanting to have us think about what we're going to do here in the implementation. Is that cleared up, Nathan?
I think we need to make an application. That way, the interface gets implemented into it.
Yeah, correct. Well, we want to implement the interface. Robert wrote that. And Nathan, what you're saying, we also want to do the application, but I would argue that the thing that has to come first is we have to implement this interface and what that means. And so we have here an array bag. And so what this means is we're using a certain way of implementing it. It's a bag, but it's an array bag. And so this is going to be the thing that we're going to need before we can move on to the actual .java file that has the main. And so this is what we have that we've seen. So you have like, we're using generics, so we don't need to be talking about any particular type of thing. So what we're going to see with this piggy bank, we're going to be talking about coins and of a certain denomination. And so those are things that we have. And these are the typical overhead that we've seen in the videos, that we have a default capacity and then we have a maximum capacity. And so if you don't declare anything, it says that, okay, your array size is going to be 25. And if you wanted, you can make your own capacity, but it's going to check that it needs to be less than a maximum capacity. So if you want to make 20,000, it's going to say, nope, it's going to be 10,000. That's the maximum value. So this is, we have these two constructors. So we have, first, it would be giving the default capacity, and then it would flow to this next, or you could have this other constructor that would, in this case, it would use that number that you're having. And so here we see an example of polymorphism. And so we're both calling array bag, but this one we're saying with the desired capacity. And so this is what we do when we're calling that method. And so that's a possibility. There is some logic. So we have some private methods here. So I'll just go back to show you this. So these are the variables that we have. If this is green, it means it's public, and the ones with the square, the red square, this means that they're private. And so if we're doing an array implementation, these are the things that, in terms of the most robust way, that with this type of implementation that we need. And so we can check to see if the array is full, get indexed. We can remove an entry and check integrity. Those are the things that are there. And so we get a chance to be seeing that. So if we say something is larger than 10,000, we're going to get this. And so we're going to would throw in an exception and it says, okay, no, you got to do some other value. And so this is the thing that we've just begun to introduce, some of the things that are going on with exceptions. So that's those things. And now in comparison with the sample code that I shared with you, this is more robust. It has a couple other things. And so here we have this check integrity. And so it's not going to be as clean, but if we could literally take this out, this is just a nice to have, as well as this is array full. That's a nice to have, but if we take that out, we're not going to know. We're taking away some of the insight that we have heard when we were going over the material in the video notes in our lectures. So so we add And so basically whatever is passed to this method is then added to the item. And so then we increment the number of entries. And so that's what we see with that implementation of the add. And then we return the result. So we return that. And so it defaults with the result being false, but as a result of doing this, the result is going to give a result that, okay, no problem. We don't have a full bag. And so you go in and add that. The array. So this is the first thing is we check the integrity. And so that's a private method. It's down at the bottom. Let me just do it this way. So check integrity. This is throws an exception if an object is not initialized. And so that's what that does. So let's just go back up. And so the Boolean, the result equals true. And then, so if the array is false, then we change the result of the to false, and that's what we have. And so this is an add. So we put that entry into the last item into the array that we're using to have our facsimile of what a bag is. And then we increment the number of entries because we've added one. So that's, we have a generic add. We have an add a particular item. I'm sorry, we just have one add, but we have two. We have one add, but we have two removes, a remove of something and a remove of a particular item. Those are the possibilities that we have in that front. So this should be familiar with the project you guys are doing, just thinking about this making and implementation of the interface. The to array, once again, we do a check integrity. This is one of those things that we saw in the videos that's kind of complicated because we're using this generic and we have to say, okay, yes, we know what we're doing, so we don't need the warning. I do go ahead and do this. And there was a particular way that they had that we would go about doing that type of function. So you just can keep that in mind if you want to be using this type of implementation. You have something like this already with the sample code. And so you can do it that way if you would like. But the end result is you stick everything out as an array and return that array. And so that's what we have here. So we have an array of however many elements are the number of items in the bag. We have a check to see if it's empty. And so this is where we use one of these variables that we defined at the very beginning. It can be saving us some time. So we keep a track of the number of entries. So this is a piggy bank. So we're going to keep track of the number of coins that are in the piggy bank. So that's the first example of this being a smart piggy bank. Get the current size. And so what this does, it just reports back the number of coins that are in the piggy bank. So that's what that does in this case. So say we want to see how many quarters are in there, we pass that to this. And then what we do is we iterate. We don't use recursion. We haven't really talked about incursion yet. And so just as long as there's a quarter, using that as an example, it's then going to increment this counter. And finally, it's going to return the counter. So that's how we have the get frequency in this situation. So we want to see, does it contain a quarter? Using that same analogy again. And so once we get past the integrity, we get the index of that entry. So if it at least finds one, that's going to come back true. And so it's just giving a Boolean return, but just as a result of doing this comparison is how we get that Boolean coming back. Finally, we do clear. We actually, for this method, we use another method. We use the let me just double check this. Yeah, so we use the clear. We use the is empty in the clear, and that's how we just remove one item at a time to clear out the bag. We don't just turn it upside down and just dump it, if you will. We literally just take out one at a time the way that it works. So this is just remove anything. So you just remove one item and then it reports back what item has been removed. And let's say you want to remove a quarter. And so it goes looking for a quarter. And if there's a quarter, then it's going to remove that. And then it reports a Boolean, either this was true or this was false as a result of that. And that's all of the public methods. The rest of it gets into the implementation. And so we've talked about that already. So you have a little bit of an insight of what's going on there. So this is that's the second one. So we have the interface, we have the array bag. And so next we'll just go over the application. This is for a piggy bank, but there's actually a couple other things that we need to be thinking about, but we'll just go ahead and do this first. And so we're calling our piggy bank my bank. And so we add a couple coins. And so here we have a cent, so 1 cent, 5 cent, 10 cents, and 25 cents. So a penny, a nickel, a dime, and a quarter, as we're familiar with the currency we use here. And so we also have thus we're going to be getting information about the amount as well as the year that the coin was minted. So it's actually doing some careful screening as you put in a new coin. And so this is how one of the ways that we can be loading up a bank. So first we create the bank and then we add coins to that bank. And so this is what we get a chance to see how that works. And so add coin. So this handles some of the things. It's a private method. And so it gets us the coin. And so we know that it's of the type coin, and we'll get to that in a minute. And so we get some nice terminal feedback. Okay, we got a coin of some type, and just as long as the bank still has capacity. So a bank is only so full, and sometimes when you get a full bank, that means something. That's like you could go take it and go buy something if you had like a bank when you were at home as a kid. So that's the next thing that we have. And so we have the bag interface, we have the implementation of the bag, we have the program that has the main, we have that, but there's a few other things. Then this gets into how you're doing an implementation of an application. And so the piggy bank. And so this is where we get into some of the specifics about, well, what are you going to do with a piggy bank? You're going to add, you're going to remove, you're going to check if it's empty. And so this is kind of almost like a wrapper, if you will, for the implementation of all of the methods. So you have the interface defines the must-have methods, the array bag implements those. Plus you have a few private ones for if you have the characteristics of the type of implementation that you have. Then we have the piggy bank example where we have the main. Now we have these specialized methods that are the way that a piggy bank is going to act. So it's a more specialized kind of bag. And so these are the ways that we're going to make it known to the way that it's going to be used. And so we have that. And then finally, we want to be managing the way that we do the coins. And so this is where we have penny, nickel, dime, quarter, 50-cent piece, dollar coin. And also we have the default. This is something else that they put in their code that you can see. There's also two sides of that coin. So there's a heads and a tails. So that's another thing that's helpful. And the defaults that to the head side is well, it just declares a variable to give us information about what side is up. And then finally, this fairly simple. This is the what are the coins that we're going to be using. So if we're in the United States, this is what we're going to be using. If we were in Canada, we'd be using the Canadian currency. Some of it would be similar, but not necessarily exact. We notice that we don't have like any other currency. It's still not as popular, but say getting more popular is a 50-cent piece and a dollar. So those are included. And so those are the things that we have. Well, let's go ahead and do an execute on this. And so if we just click on it, we don't actually need to have any user input. It does it all for us. And so we add a penny, a nickel, a dime, a quarter, and then remove them one at a time, a quarter, a dime, a nickel, and a penny, all done. And then we can tell how much we remove, 41 cents. That's what we have here for this implementation. So for a bag implementation for what you're doing for your projects, this is the kind of thing that you could be doing. And so you can keep that in mind. So let me stop sharing for a minute to see if there's any comments or questions on what I shared.
So with this project the project that you showed, the example project, is that something like that's something we have to do, right? With all those classes, or can it just, we don't have to make that much?
Well, I actually previously was sharing this as an example project, and it was so complicated, I think it got people confused. So this is more than what you need to do in your project. So what you need in your project, you need to have an interface, an implementation, and an application program. That's it. 3 .java files is all you need to have. If you wanted to do more, and I've heard some people talk that way, then it gets into stylistically what you need to be capturing. Do you want to create a separate class, like a coin class, or not? So they chose to have an extra class doing it that way. They chose to have another class for piggy bank. So it's like a physical thing that you're using. And so that's an important thing to make sure that is declared. That's, once again, is not necessary. You could just have maybe a higher abstraction of what you're trying to accomplish if you were to try to go along with this type of a theme. Does that help, Nathan?
Yes, it does. Thank you.
Could you
Okay.
repeat what Java files you wanted again? The 3 Java files. So one is the interface.
Yeah, the bag interface.java.
Yeah.
So then you're going to have like a array bag.java if you want to do an array implementation, or you'd have a link bag.java if you wanted to be doing a linked implementation. So these are the two things that you would have. And then you want to have one other .java file as a minimum for an application. Like some of the folks that I've talked to, say if you're going to be doing something with video games, or in previous years, one student was doing something for the Tour de France. And so this is where you're actually trying to take what a bag has in terms of its capability and apply it to your area, your domain. So it was Tour de France, and so you're just going to do a collection of the top 10 riders. That would be what the application would do for a bag. Then you could add or remove. There's other things that you could be doing, just like with the piggy bank. They did a couple extra things. When you actually are recording what year is the coin. I like to collect coins. I don't do it much now, but I still have ones that I've collected a while ago. And like I remember, I have like an 1889 silver dollar. It's probably one of the nicest coins that I have. And so this is one of the things that's there. And you're not just saying that, okay, this bag can hold 50 coins. There is some kind of limit to what you can have. And I think I'd have to double check with this, but I think the way they would do it here with an array is you can only have up to the maximum number that's allowed here, which would be something like 10,000, unless they modify this someplace else, and I'd have to go through the code to see if there's another place where that shows up. So just the three minimum things are those three .java files, okay? Any other questions or comments?
Oh, I also kind of forgot the quiz part of it. You just want like just if the code works and like
Yeah.
basically talking about it.
So first of all, you have a paragraph that says, what does it do? So you know the big picture, what you have with your proposal. Okay, now what are you trying to accomplish with a bag? Then you have one of the questions is, does it work or does it not work? And then you can describe that in a little bit more detail. Then sharing your sample code. It's easier to view it if you put it in as text. So do that. And then there's another question where you can just create a zip file and create and include your whole project. Okay.
If we answer like if the code doesn't work, does that mark off points?
Maybe I'm sure you've had this experience where you've taken a physics exam and there's like a couple scenarios of the possibility. You have one person that all they do is write the answer. And when they get their test back, they says, well, they got the right answer, but you didn't show how you got there. And so they got marked down. Well, similarly, if you have all of the work, but you have the wrong answer, you're still going to get a lot of credit because you're showing that you've actually been engaging with it, and maybe you just had some type of algebraic error that you made when you were coming up with a final number. So show your work. If you don't have it working, go ahead and submit it. For each one of these assignments, you can resubmit. So say you come back to it. I can't tell you how many times that I do some coding and then I set it aside and come back to it the next day. You got a fresh set of eyes and you might end up figuring out what's going on. But the commitment I make to you is when you resubmit, you'll never get a lower grade than what you got initially. So it's only a benefit that you have the potential for getting a better grade. Okay?
Okay, thank you, Professor.
Sounds good. Any other comments or questions? Okay, well, I think what I'll do is I'll go back into just a few minutes of lecture mode, and I apologize for having problems in the beginning, but I was able to flex enough to get things to work. So let me get Canvas back up and running. So we just started to go into stacks. So this is the number 2 of the 7 that we're going to be going over in class. And so what we did is we did a general introduction to stacks. And we're gonna have the second companion video for that we'll go over. So and we're going to start to introduce some terms, POSIX, infix, prefix, these types of things. We're going to be coming back to this several times, but this gets into some useful tools that are going to be helping us as we start to think more about algorithms and possible strategies for how we're going to be going forward on a few areas. So let's just click over to, okay, where'd it go? The second video that just introduces it, and then we'll start to be thinking about the array and the linked implementations. Let me see if I can get this working here.
In mathematics, an algebraic expression is composed of operands that are variables or constants and operators, such as plus for addition and the asterisk for multiplication. So on Tuesday, we started to talk about this, but we didn't have these some of these other things that we have this way of getting more fidelity of how we handle complex expressions. And so that's what this is going to introduce. And then we'll see how this infix, postfix, prefix, those kind of stuff are going to be able to help us. We use a caret to indicate exponentiation with the warning that Java has no operator for exponentiation. In Java, the caret is the exclusive OR operator. When an algebraic expression has no parentheses, operations occur in a certain order. Exponentiations occur first, they take precedence over the other operations, and next multiplications and divisions occur, and then additions and subtractions. For example, the expression 20 minus 2 times 2 raised to the third power evaluates as 20 minus 2 times 8, then as 20 minus 16, and finally as 4. Operators generally have two operands and are so-called binary operators. For example, the plus in 4 plus 5 is a binary operator. The operators plus and minus can also be unary operators when they have only one operand. For example, the minus sign in -6 is a unary operator. Ordinarily, we place a binary operator between its operands, as in 5 plus 6. An
Excuse me,
expression
Professor?
of familiar notation is called an infix.
Yes.
We can't see the screen.
Oh, I'm sorry. I thought I was sharing my screen, but thank you for telling me that. That defeats the whole purpose of doing this. So let me, I think Zoom keeps changing itself, and usually there's a line that appears around the screen that I can get some positive feedback that I'm sharing my screen. So I'll just go back some, and I apologize for that.
Of
You're okay.
operands
Thank
that are
you.
variables or constants, and operators, such as plus for addition and the asterisk for multiplication. We use a caret to indicate exponentiation with the warning that Java has no operator for exponentiation. In Java, the caret is the exclusive OR operator. When an algebraic expression has no parentheses, operations occur in a certain order. Exponentiations occur first, they take precedence over the other operations, and next multiplications and divisions occur, and then additions and subtractions. For example, the expression 20 minus 2 times 2 raised to the third power evaluates as 20 minus 2 times 8, then as 20 minus 16, and finally as 4. Operators generally have two operands and are so-called binary operators. For example, the plus in 4 plus 5 is a binary operator. The operators plus and minus can also be unary operators when they have only one operand. For example, the minus sign in -6 is a unary operator. Ordinarily, we place a binary operator between its operands, as in 5 plus 6. An expression in this familiar notation is called an infix expression. Other notations are possible, though. For example, you could write a binary operator before its two operands. Thus,
So some of this is going to look kind of strange, and why would you ever do this? And this is where we'll start to see how this plays out with say if we want to do sorting, we're going to see that there's some advantages from one way or another. So just keep that in mind. There's going to be some applications where you're going to see how one or more of these is going to be useful as we get more into the more complicated abstract data types.
5 plus 6 becomes plus 5, 6. This expression is called a prefix expression. Here are the three expressions shown above, but in prefix notation. You could write a binary operator after its.
Now, I mentioned this the other day, this reverse Polish notation, and so the more correct way of calling it is postfix. And so if you wanted to add two numbers, you put 5, and then you put in 6, and then you put in plus. So you don't have parentheses. You have to be the one that sort of knows what the precedence is, and then you put in the operators after you put in the numbers to make sure you get those things in the right order.
Two operands. So 5 plus 6 becomes 5, 6 plus. This expression is a postfix expression. Although infix expressions are more familiar to us, both prefix and postfix expressions are simpler to process because they do not use precedence rules or parentheses. The precedence of an operator in either a prefix expression or a postfix expression is implied by the order in which the operators and operands occur in the expression. This can make them easier to evaluate, so let's look at converting an infix expression to a postfix form. We scan the infix expression from left to right. When we encounter an operand, we place it at the end of the new expression that we are creating. When converting, operands and infix expressions remain in the same order in the corresponding postfix expression. When we encounter an operator, we must save it until we determine where in the output expression it belongs.
So this is going to be a stack. And so this is where in a more complicated operation, we're finding that it's useful to have an abstract data type. We could have other data types as well when we get into the application. But what we're doing in this course, we're trying to parse it down to, well, let's focus on one ADT at a time.
For example, to convert the infix expression 5 plus 6, we append 5 to the initially empty output expression and save the plus, and then append 6 to the output expression. We now need to retrieve the plus and put it at the end of the output expression to get the postfix expression 5, 6 plus. Retrieving the operator saved most recently is easy if we've saved it in a stack. In this example, we saved the operator until we processed its second operand. In general, we hold the operator in a stack at least until we compare its precedence with that of the next operator. To convert the expression 5 plus 6 times 7, we append 5 to the output expression, push plus onto a stack, and then append 6 to the output. What we do now depends on the relative precedence of the next operator, the multiplication symbol, and the plus symbol at the top of the stack. Since multiplication has a greater precedence than addition, 6 is not the addition's second operand. Instead, the addition waits for the result of the multiplication. Thus, we push the asterisk for multiplication onto the stack and append 7 to the output expression. Having reached the end of the input expression, we now pop each operator from the stack and append it to the end of the output expression, getting the postfix expression 5, 6, 7, asterisk plus.
So we're getting a chance to see, these are the ways that we're used to seeing this. As we could just eyeball this and come up with the right answer. But these are these other things that a computer doesn't really have, it doesn't have parentheses. So we're putting this into the kind of mode that's going to be easier for a couple of different ways when we think about it from a computing point of view.
Evaluating an infix expression is a complex process since the order of operands does not imply precedence. Additionally, parentheses can change the default precedence of operators. To evaluate an infix expression, it's simpler to first convert it to a postfix expression, and then evaluate the resulting postfix expression. Let's see how we can use stacks to help us with this. Let's look at the algorithm that can help us convert an infix expression to a postfix expression, even if the infix expression has parentheses. When we encounter an operand, we place it at the end of the new expression that we're creating. When we encounter an operator, since the operator stack is empty, we push the operator onto the stack until we determine where in the output expression it belongs.
So this is where we're starting to lay out an algorithm. Remember, we talked about a bag behavior. Now we're talking about a stack behavior. Now we're talking about applying some of these things to do a capability, to do expression analysis. This is also stuff that is relevant for developing a compiler that will also hit that application as we continue on through some of these video notes.
We'll look at the operator algorithm in more detail shortly. Parentheses can change the order of precedence, but they're not part of a postfix expression. Since parentheses override the rules of operator precedence, we always push an open parentheses onto the stack. Once it's on the stack, we treat an open parentheses as an operator with the lowest precedence. That is, any subsequent operator will get pushed onto the stack. Later, when we encounter a closed parentheses, we pop operators from the stack and append them to the forming postfix expression until we pop an open parentheses. The algorithm continues with no parentheses added to the postfix expression. At the next operand, we append it to the postfix expression. When we reach the addition operator, an open parentheses is on top of the stack since it has the lowest precedence. We push this onto the operator stack. We move the operand 2 to the postfix expression, and then we reach a closing parentheses. So we pop each operator off the operator stack until we reach the matching open parentheses. We then discard both the open and closed parentheses since they're no longer needed. Whereas addition, subtraction, multiplication, and division have left to right associations for their operators, exponentiation has a right to left association, so we must ensure that the right-hand operator is always evaluated first. This can easily be accomplished by always pushing the exponentiation operator onto the operator stack.
So basically, this isn't quite pseudocode, but it's giving us the requirements and how it has to operate. So this is an important thing, especially if we're not familiar with an algorithm that can go from infix to postfix, as we're talking about here. So we're laying that out as we go.
The last operand is then appended to the postfix expression. Now that all the characters have been processed, we can evaluate our postfix expression. We can use a stack to help us process the postfix expression we just created. Evaluating a postfix expression requires no rules of operator precedence, since the order of its operators and operands dictates the order of the operations. Additionally, a postfix expression contains no parentheses to complicate the evaluation. As we scan the postfix expression, we must save operands until we find the operators that apply to them. For example, to evaluate our current postfix expression, we save each operand by pushing it onto our operator stack. When we come to an operator, we pop 2 values from the stack to serve as operands. After evaluating the expression, we push the result back onto the stack. We then continue this simple algorithm until there are no characters remaining in the postfix expression. At that point, we've evaluated the postfix expression and we have our result. Now let's describe our algorithm for evaluating infix expressions in more detail by putting together some pseudocode. We can begin by converting the infix expression to its postscript form. We are given the infix expression to process and will create a stack, operator stack, to use in managing operator precedence in parentheses. The postfix expression will begin as an empty string. When we're finished with this step, it will contain the converted postfix expression that we can evaluate. For each of the characters in the postfix expression, we process the character as discussed earlier. Let's take a closer look at our algorithm for processing each of the infix expression characters. The first case is if we have a variable. we append it to the postfix expression. Then, if we have exponentiation, we can push it onto our operator stack. It's the highest priority. An open parentheses is pushed onto the operator stack also, so they can increase the precedence of any following operators. When we process a closed parentheses, we pop each of the operators off of the operator stack until we reach the matching open parentheses. The operators are appended to the postfix expression and the open parentheses is discarded. If we have an operator, we need to remove any higher precedence operators from the stack and append them to the postfix expression. This switch case statement ensures that operator precedence is handled correctly and that operands are matched to the correct operators in the resulting postfix expression. Returning to the first part of the algorithm, we must now pop any remaining operators from the operator stack and append them to our postfix expression. At this point, we're ready to evaluate the postfix expression. Here is pseudocode that.
So I'll come back to this in a second, but one of the ways you see that they're using the names actually to help having comments, if you will, to make it easier for someone to trace through the code. And so I would recommend that you think about doing that as you're developing your projects, just as a nice way of doing that, using Camelback notation. We can see capital E there, capital E, operator stack. Those are also some things that you can note.
Operands and the results of our operations. Then we examine each of the characters in the postfix expression. If it's a variable, we push its value onto the value stack. If it's an operator, we pop the top two values on the stack and use them as operands for the operator.
Okay, so what have we done in these two video notes on stacks? We've introduced what it is. Now we've given an example of how it can be used. We now have the pseudocode. And next, what's going to happen when we start to be looking at the implementation, we're going to be looking at the implementation of this kind of stuff. Either we'll do it both with a array stack and a link stack. And we'll be getting to know not only more about this ADT, but some more ways and things that start to come up as useful features for both an array and a linked implementation.
When there are no characters left in the postfix expression, we can peek at the top of the stack and see the result of evaluating our original infix expression.
Okay, so that's the second part of an introduction. And so what we have, I think I'll just do one more. And previously, when we were doing things in bags, we started with arrays. Well, we're going to start with linked stacks, and then we're going to go into array stacks. And so we'll just straddle this over today and next Tuesday. But let's go ahead and play this first one. I'll go back to the lecture notes to see if there's anything that we missed, and then we'll finish up there.
In this lecture, we implement the ADT stack using a linked chain. We'll call our class linked stack. Since we're
So you're going to slowly be picking this up. If you have a linked implementation, you're going to have a node. Okay, either a node method, a node class. And so this is how we keep track of where we're at. Remember, the way that you know from one element to another in a linked is that the one node knows where the next one is. So that's how it works. And so that's the limiting way in which we know the relationships between one element and another, which is different than the way it would be laid out in an array.
Using a linked chain, we'll need a node to reference the head of the chain. We'll use the head of the chain as the top of the stack. Since if we have only the chain's head reference, we can add, remove, or access its first node faster than any other node. Thus, the stack operations will execute fastest if the first node in the chain references the top entry in the stack.
So just like we did in a bag, you have a bag interface. Now we have a stack interface. We have to implement that. And then we need to have our constructors. And so here is a simple one. You don't need to have those default size and max size with a link stack. None of that needs to be there, so we can get right into it. And so that's another distinction between the two types of implementation.
When we first create our stack, it's empty, so the reference to our head or top node should be null. Our implementation of the ADT stack method push can be similar to the add of our linked bag implementation. As each new item is pushed onto the stack, it is added to the head of the chain. The first statement in our push method places the item in a node and sets the next field of the node to the current top of the stack. The second statement sets the top of the stack to be the new node we just created and pushed onto the stack. The process is then repeated for each of the following items that we push onto the stack. This operation is independent of the other entries in the stack. Its performance is thus order of at most 1. Now let's look at implementing peek and pop. Peek returns the item at the top of the stack. We get to the top entry in the stack by accessing the data portion.
So I'll ask it as a question rather than just lay it out there. So does it leave the item on top of the stack, or does it remove it? Anybody have an idea or a guess?
Does it leave the top?
Yeah. So that's the difference between peek and pop. And so we'll want to keep that in mind.
Of the first node in the chain. Thus, peek, like push, is an order of at most 1 operation. Note that if the stack is empty, peek throws an exception. Our client can catch this exception and act accordingly. Peek does not change the structure of the stack. We can use our peek implementation to help simplify our pop implementation. We first execute peek to retrieve the item at the top of the stack so that it can be returned to the client. We want to be careful to not return this value immediately after retrieving it. If we execute a return statement here, our method will terminate and will not have removed the top node as is required in the definition of the ADT stack method pop. Once we've saved the item on the top of the stack so we can return it to a client, we can remove the top item on the stack. Since this is the first node in our chain, we can remove it by setting our stack top data field to the second node in the chain. The method pop for the linked stack is also order of at most 1. The rest of the linked stack class's public method is empty and clear, only involves stack top, and are simple to implement.
So, this is an example. You have these code stubs, and these are actually complete. These are the things that are in the textbook. And so I've provided all of the sample code that you can be leveraging when you get into doing the stack implementation. So keep that in mind.
Simple to implement.
All right, well, we'll just finish up. So just as a reminder, the things that are available. So here is the download for all of the code that's in the textbook. And so I just got this from the website for the publishers. It's also that you could actually go there and get the same thing. You have the sample project with the simple bags. It does a driver. It doesn't have an application, so a slight nuance there. And so those are things that you want to make sure that you take advantage of. So I think that's all that I've got for today. So I'm sorry about the snafu in the beginning.